All right. Welcome everybody to our customer story series where we highlight some of our customers at Zenlayer and the big impacts they're making on the internet as a whole, especially around acceleration. Really want to introduce here Glenn Fielder from Network Next. Glenn, why don't you tell a little bit about yourself to the audience?
Cool. Hey, thanks for having me. I'm Glenn. I'm an Australian American living upstate New York, and I've been in the game industry for 25 years. And I specialized in writing netcode, which is the custom UDP protocol for multiplayer games that makes the game work over the internet. I've worked on some games like Titanfall, Journey, Mercenaries 2, God of War, and some of my netcode is actually still even in Apex Legends. So now I'm an entrepreneur in the multiplayer game space, and I have a startup called Network Next that does acceleration for multiplayer games. And Zenlayer is one of the core suppliers for that acceleration program.
Mm-hmm. And with your history of working on AAA games, especially on netcode, I'm sure you've ran into a lot of latency challenges you've had to solve for players all around the world. So tell me how that led to starting Network Next.
So with all of these multiplayer games that I worked on, you launch the game and you think you've done everything you can. You've written the best netcode that you can. You've networked the game code the best way. You've made the game code tolerant of latency to a point. But what I found was over and over when I kept launching these games that no matter what I did, the internet kind of would give some players, like maybe 5 or 10%, not 100% sure, but there would always be people complaining that the game had lag. And it's really frustrating as someone who creates a multiplayer game. You want everyone to have a good time. So I started looking into it, and after shipping a couple of games and realizing the problem wasn't actually me. The netcode was fine, the server hosting was fine. The problem was the internet. So in 2015, I started Network Next to solve this problem. I wanted to make sure that instead of best effort delivery from the player to the server where the game's hosted, I wanted to make sure that the player would always take the lowest latency route.
Yeah, and go into the challenges of the internet, right? Like what about the way the internet was built kind of causes this latency for players?
So when I first started this, I don't have a network engineering background. I'm really a custom UDP protocol writing kind of guy. So I don't have a network engineering background. I don't know how to configure BGP. I don't come from a hosting background. So I had to learn a lot of the stuff about how the internet actually worked, because I was really coming at it from a software side, just sort of asking the question. I've experienced over 10 years that some players are getting really bad network performance, even though their ISP connection is good, even though they have a good computer, even though I've got really good server hosting for my game. And I started to think that it could be a systemic problem. So what I learned was, while network neutrality and best effort delivery are sort of foundational to the internet that we know, it's not really meeting the needs of video games that have real-time time series data that ideally I'd be sending packets 60 times per second that arrive with minimal latency, zero packet loss, and exactly a 60th of a second apart. But the internet tends to clump packets up, send packets down different routes depending on the time of day. I sort of think of it like there's 4 or 5 different companies in between you and the server, disinterested entities that really don't have any financial incentive to make sure that your traffic goes the right way. They just kind of throw the packet over the wall. This is server.
Yeah. So ultimately, it's no, like, doesn't matter how good your net code is in the game. It's
or even
systemic.
how good your server hosting company is, because you must have a good server hosting company, but you can't possibly have one server hosting company that is optimal for every IP address at every time of day in every country across 100,000 different ASNs. the network is just so large that at some point there's going to be misconfiguration, there's going to be hairpins, there'll be a link down, and the internet as it exists right now just kind of goes, I'll make reasonable effort to get the packets there, but it really, the key thing is that this is not anything looking at your player's route end to end
Yeah.
and going, let's make sure that this always takes the lowest latency path right now for this player at this IP address at this port to this server at this port. Let's make sure that it always takes the lowest latency route. What actually happens is that the routes tend to be load balanced.
Yeah.
So depending on the port number of the client or the server, it can take a completely different route, even for the same player on the same IP address to the same server on the same data center.
Yeah.
If the port number changes, that can actually cause a hash change that makes the route configuration go left instead of going right. So that's really what's actually happening here. The internet is load balancing extremely latency sensitive traffic across routes that don't necessarily have the same network performance characteristics. So sometimes it's good, sometimes it's really bad.
Yeah. So what I'm understanding is basically for a game developer, no amount of net code optimization or server performance, other than maybe, really pushing things out to the edge and having your game server in every single city, which causes a bunch of downstream challenges, can overcome these routing issues, right?
Yeah. To be kind of really specific about it, even if you had millions and millions of players and your game was large enough to not have fragmentation, even putting a server in every single city wouldn't be enough to fix this routing issue. We actually see players in Los Angeles going to really high quality game servers or clouds in Los Angeles taking hairpin routes that we can reduce by like 150 milliseconds plus. We've even seen Google Fiber have a bad route to Google Cloud. So the internet is much worse than it's much worse than anyone imagines it is until you stare at 100,000 players, and the routing decisions that are made. It's sort of like Blade Runner. It's like, I've seen things you people wouldn't believe.
Yeah, yeah. So how does Network Next specifically kind of tackle this challenge head on?
Cool. So what we found was, and this again is my bias, I come from the software side. So I'm kind of coming from the software down to the network side. I don't, my first instinct is not to be like, oh, cool, I'll just use Anycast and set up a network and then my network will solve the problem. I'll have the best network in the world, right? My solution was sort of coming from the other direction of software. So I started by putting some code in the client and putting some code in the server and actively probing between the client and the server to see if the route right now while they're playing the game is optimal. And then whenever I find that the route is not optimal, instead of setting up a network, I rely on other companies' existing networks like Zenlayers. So if I see that somebody while they're playing the game is having high latency, packet loss, or jitter, what I do is I steer the traffic through relays that pin the route, that makes it go the lowest latency, uncongested, zero packet loss, low jitter path, when the default route from BGP might be a hairpin or might be congested or might have other problems.
Yep. And from what I understand, you accomplish this using a SDK. It's open source that anybody can integrate into their game.
Yeah.
Right. And since you were working on the software layer, this is kind of like the entry point to this route optimization.
That's right. I mean, everybody wants a magical solution that, like, I don't have to change my game. Why can't I just optimize any game? And the answer is, we can find route improvements that other solutions built around Anycast or traditional networking can't find, because we're actually in both of the endpoints. So I can't convince the internet not to do best effort delivery routing end to end from client to servers for games. There's no RFC that I can write that would get accepted by anybody in 2026. So what I do is I actually accept that I'll have to be in both endpoints, in the client and the server, And I tell you literally, like when I say pinning the route and sending through relays, there is some magic on each of the relays, forwarding the packets and cryptographically identifying actual valid traffic for the game, dropping it relative to DDoS or unauthorized traffic. But when it comes down to the SDK, the steering of the traffic is the client literally sends the game UDP packets to the first relay's IP address and port. The first relay sends the packets to the address of the second relay, which then forwards it to the game server, and everything in reverse on the way back down. So I don't do anything at the network layer at all. I'm literally just sending UDP packets from the client and the server and steering how they go. And paradoxically, sending through these relays, it's actually how we find all the acceleration.
Yep. And it's these relays then you deploy them in different bare metal and cloud locations, so you can sort of create a web that finds the optimal route for each player.
Yeah, it's really a routing mesh, and it's doing two main things. The first thing it's doing is all the relays are pinging all the other relays all the time, 10 times per second. And then I use that to build up a what I call a route matrix, which lets me look up in constant time the lowest latency, zero packet loss, zero jitter routes, a list of all of those that are paradoxically faster than just sending from that relay's IP address to the other relay's IP address. So that's how I can send through routes that are up to 5 relays long. And the second thing they're doing is the SDK, when you start the game with our SDK included, the SDK in the client is actually pinging nearby relays to the player using IP2 location. And that gives us the first hop cost from the player right now with their IP address import as of that game to enter the relay network. So in effect, we've now got complete control over the initial route hop to the first relay, and then a controlled, optimized route across the relay network that then drops it right into the data center where the server is hosted.
Yep. So being a gamer my whole entire life, right? Obviously latency is very important, but there's a difference between latency sensitivity based on different games, right? Some games like first person shooters have a very high latency sensitivity versus other ones, maybe real-time strategy games, turn-based games, etc., are much more latency tolerant, right? So what kind of games, how does Network Next handle this sort of disparity in the sensitivity to latency?
Yeah, this is absolutely correct. So when we were first starting Network Next in 2018, we went around and talked to all my game developer friends and asked them what they were looking for, and pretty much 0 people were interested in reducing a player's latency from 31 milliseconds down to 29. Nobody cares, right? So one of the things about the tech that we focused on from day one was we only want to accelerate players when it's having a really meaningful impact to this particular game. And the way we do that is we let the customer say, well, my game plays pretty good up to 100 milliseconds. Or no, my game is very latency sensitive. In fact, we actually worked with ESL for professional play a few years ago for some tournaments. And it was in that case, actually every millisecond was important, but that's incredibly rare. For most games that we work with, it really is. My game is absolutely latency sensitive, but to be fair, if it's less than 20 milliseconds, I don't want to pay to make it 15, right? So what we landed on was this sort of setup that we actually call it a route shader. It's a little kind of like a vertex shader or a pixel shader. We thought that was a little cute. And the idea is that the game itself actually specifies how it wants traffic to be routed to it. Okay, so a game can say only accelerate traffic if the latency over the internet for this player is above 50 milliseconds. Any number, could be 100, could be 150. And only if you can reduce it by more than X. So most customers we work with, they'll say only 10 milliseconds reduction or more. And The other thing that's really cool is that everybody agrees that any amount of packet loss is bad. So generally speaking, if we see any packet loss for that player, we'll accelerate them. And also if we see some jitter, which is the time variation in RTT,
Yep.
if we see that, we can often reduce that as well. One of the things that we do is we actually send the packets across both the internet route and the optimized route at the same time. So doing that, we find that on average, packet loss is halved. And most of the time, our customers end up accelerating around 10% of their players. So it's really cost effective because you can imagine, obviously, accelerating 100% of the players would cost 10 times more than that.
Yeah, let's dive into that a little bit, because this sort of dynamic model of acceleration, right, is probably extremely beneficial, both financially to game developers and in terms of the their net code and how they're kind of thinking of latency optimization as a whole, right? So how many players on average get acceleration from Network Next for any given customer you have?
I'd say 5 to 10%. So 5% would be a game for which it's not particularly latency sensitive. 10% would be the average. We have had customers where we've done 100%, but that's extremely rare. And one of the things that I find really interesting is even though we're doing 5 or 10%, it's not the same players each day when we look across them. Because it can kind of sound a little anemic. Well, this product only accelerates 5% of players. Well, no, hold on. That's at any time.
Yeah.
So what we've found is when we look at the data across a month, more than 60% of players are accelerated at least once. So we have this kind of internet weather that's moving around across your player base, affecting much more than 5 or 10% of your player base over a month. And then in addition, if you think about it, if you have a 64 player game like Apex Legends or something like that, as the player counts increase, the chance that one of those 5 or 10% are in a match with you and you're interacting with them and it's giving you a bad experience, even though you don't have high latency, is basically 100%. So, in the last 10 years, what we found is targeting the players with really bad network performance has an impact across the entire player base, not just the people getting accelerated that time.
Yeah. And the latency impact has a downstream effect, right? Because it's these 5 or 10% of players that are writing bad reviews on Steam, that are rating your game badly, that are complaining on Twitter and on Reddit about your game, right? So it's really like optimizing this to improve their experience, but also, in the highly competitive space that multiplayer games are, it's really in improving the overall chance of success of your game by delivering a awesome experience to the widest amount of players.
Yeah, I mean, truthfully, at Network Next, we can't make a bad game good.
Yeah,
but we can absolutely get the internet out of the way of a good game.
I love that. Yeah,
helping everybody have it. I mean, the number of people who are in South America, the Middle East, or Southeast Asia who have just normalized having a bad experience playing games for no reason other than the structure of the internet. I mean, it's personally very frustrating to me. People who are used to playing with randomly 100 milliseconds to 300 milliseconds, depending on the time of day they're playing. We can do better. We can do a lot better than this.
Yeah. So for those 5 or 10% of players, what kind of improvement can they expect to see?
The whole show don't tell thing?
Yep.
I don't want to tell, I'll show. So let me throw up a screen share, and here we go. It really depends on the difference between the route that the player is getting right now and the optimal route that exists for that player to that data center. So we obviously can't take someone from Beijing to the other side of the planet, right, in less than the speed of light, 2/3 time for the fiber optic cables between them.
Yep.
We don't lay down fiber where it doesn't exist. But what we can do is we can look at thousands of different ways to get each player from where they are physically located to the server, to the data center where the server is physically located. And we make sure that that path is the absolute optimal minimum latency path for that player, literally every 10 seconds while they play. So what we've got here is actually live from a customer. So you can see that we're actually at off-peak time. It's in the middle of the day, but we're accelerating 567 players right now, a bit more than 10%. It goes up and down depending on the time of the day and the phase of the moon, how the internet's doing today.
Yep.
And out of 4,328 sessions or players playing right now.
Yeah.
So what we're looking at right here, each line here is a real player right now. So right now we have someone in India on the ISP AsiaNet going to i3D Dubai. And i3D actually, no shade at all, i3D is an excellent hosting company. It's well known for having extremely good networking. They've got very good peering and interconnects, right? I would say that they'd be a peer of Zenlayer.
Yep.
Right? But even so, here we are taking someone in India to i3D Dubai data center, reducing their latency by 246 milliseconds.
Yeah, this is incredible, because 246 milliseconds is basically taking an unplayable connection and making it very playable. And what's really cool here is you kind of see the connection as well.
Yeah,
Like
it's
you see some
Wi-Fi.
wired. Yeah, that's Wi-Fi. You see some wired connections. So these folks are already like trying to optimize their connection as much as possible. They're not using Wi-Fi. They're plugging directly into their PC, and we're still able to accelerate them.
So this particular person is on Wi-Fi, but I'm pretty confident Wi-Fi is not the problem. Because if you think about it, if it was the Wi-Fi, we wouldn't be able to fix it.
Yeah.
Right. So here's the cool thing. I can actually click on the session live, click on the session ID, and actually view the player's session right now. So this person has been playing for about 6 minutes. And consistently, we've gotten them down from 329 milliseconds of latency. Each sample here is 10 seconds. The orange line is actually our conservative estimate of how much we could reduce latency for this player. That's how we implement the route.
Got it.
Right? Because we always want to make sure that our guess is going to be higher than the actual. We never want to think we're going to get a latency of this and then be worse than that. So it's a very conservative estimate. And then the green is the actual. So this is a person who is literally going from 329 milliseconds down to 84 milliseconds. Now, I'm willing to bet that 84 milliseconds, given the particular geography and the set of cables between the two locations, is the optimal path for this player.
Yeah.
So
this is
their jitter is going down too.
Yeah, this is so much amazing data for
this player is not
working on net code. Yep.
This player is not getting packet loss.
Yep.
But we sometimes see like 90%, 100% packet loss, or even spikes of packet loss that just aren't there in the accelerated room.
Yeah, and kind of going back to what you said before about the quality of data centers, quality of the game and the platform. In your previous screen, I saw some like PS5 and Xbox. They're going into Azure. They're going into highly optimized environments that Microsoft and Sony run, right? But you're still able to find a better path and make those games playable.
Yeah, here's someone on Series X.
Yeah,
it's probably one of the streaming Series X because their ISP comes up as Microsoft Azure.
Yep.
Okay. So I'll bet that this is a Series S, Series X. Yep. So if I click on it, look, I mean, we're looking at 132 milliseconds down to 30. Now, Azure is not a bad network.
Of course, yeah.
Right. Latitude is a fairly good hosting company, right? But the internet in between the two networks isn't necessarily always taking the lowest latency path.
Yep.
And that's where we have the Slack, where we can actually hop in and go, no, go this way.
Yeah. I don't even know. So this kind of helps the game streaming component as well, right?
The
If
game,
it's
the game streaming side.
yeah, if somebody is using like Microsoft's cloud to stream their game, does this have an impact on it as
I
well?
think we're not getting in between the console and the data center where the client is running.
Hmm.
But what's actually happening is when they're streaming, they're actually running a client in the cloud, and then that client has to connect to a server somewhere else.
Got it. Yeah.
So it's almost like their client is located in Azure's data center, right?
Yeah.
We could technically apply this tech to game streaming, but I would say one of the really nice things about games is that they're extremely latency sensitive
Yep.
traffic. But generally speaking, in the order of things, a very small percentage of internet traffic,
Yep.
right? Very small, UDP based. I mean, it would be 0.1% or lower of internet traffic at any point in time.
Yep.
If only the internet could get its shit together and route it properly, right? It wouldn't really have any massive impact on the performance of people's networks or ISPs networks. But the problem is they can't identify the real-time traffic. So part of what Network Next is doing is kind of saying, well, if you're not going to optimize it, I will.
Yeah. Well, and this is the beauty of the internet, right? Like the internet was developed for a time that no longer exists. It's a million optimizations like this that stack up that actually make it usable
Yeah.
in the,
Thank God.
modern day, right?
UDP,
Yeah.
thank God UDP exists.
Yeah.
I mean, if you didn't have UDP, you wouldn't be able to implement custom protocols without having that protocol on every router
Yep.
between the nodes. So they did something incredibly right. It's just that the best effort routing, although it's good for high, throughput, I'm sure I'll get people with much more knowledge than me saying, well, it's not even good for high throughput. But let's just say that it's better for downloading a big file than it is for streaming real-time data that can't be buffered.
Yep.
So this is not Netflix. It's not YouTube. It's not, let's just buffer it for another half a second and then it will come out smooth. I mean, people want it to be latency sensitive and minimal latency, like 16.67 milliseconds for each frame when you're playing at 60 hertz. As soon as your latency increases by a small amount, it actually has an impact on how the game feels. So it's not that we could just buffer the game data coming from the server to the client and have it come out smooth. We actually need it to come in as quickly as possible, and that's why it's extremely difficult to implement multiplayer games.
Yep. So where does Zenlayer fit into Network Next and these optimizations?
Cool. So we've got a backend running in Google Cloud, written in Golang, and that performs all of the route optimization. So that's sort of like our control plane.
Mm-hmm.
And then we have these relays that really are like a data plane, but sort of like an overlay network built over UDP. Okay. And the nodes, the client and the server nodes, know how to speak to this overlay network because the SDK is in there. But where Zenlayer comes in is that we run relays pretty much in every Zenlayer location around the world that we can. So concretely, we get an advantage from Zenlayer's network. When Zenlayer is well connected to a particular ISP, a direct internet connect or a peering agreement or however they do it, as I'm not a network engineer, things that I don't particularly understand well.
Yeah, that's where our 10,000 peering agreements come into play. Yeah.
It makes a big difference. And Network Next is not in the business of connecting to, we don't have an ASN, we don't have a network. We are a network of networks, right? And Zenlayer is probably our top supplier for relays because they have really good connections to all of the local ISPs, rival networks, sort of in the CDN world. And then on top of that, it's not very helpful if you just have good connectivity to ISPs in the local city, because we often have to take that traffic to another country or to another city. So that's where Zenlayer's optimized backbone comes in. So,
and do you deploy some of your relays on Zenlayer bare metal or virtual machines in those areas?
it depends. So depending on the traffic load, our relay runs Linux. It
Mhm.
currently runs on Ubuntu 22.04 LTS, but most of the relay code that really matters is written in XDP.
Mhm.
It's extremely efficient. It can run in a zero copy mode on a bare metal machine with a 10 gig NIC. It can run in a copy mode, not quite as fast, but it can run in a VM like Google Cloud, Zenlayer's Cloud, or Azure, or AWS. But if there's only a few hundred sessions in Bogota, Colombia,
Mhm.
I don't need bare metal to do that.
Yep.
So I sort of right size depending on the amount of traffic going through a relay. So VMs are actually a huge part. So if we could
Yep.
have a much lower cost VM in regions that are sort of more like edge, not really edge in the edge computing sense, but in our network, we have sort of
Yeah.
trunks with high traffic and then the leads.
In the network infrastructure sense. Yeah.
Yeah.
Yeah. So how do game developers get started, right? This is obviously, something that every single game developer looks like. They're continually optimizing their net code. They're trying to kind of squeeze out performance every way they can, right?
Mhm.
What's the right starting point for a game developer?
So I just want to call out that I am a game developer myself. I would
Mhm.
be the person using this if I was working in a studio and writing the netcode for them. So we really have designed this for you. This is an open source SDK that integrates into your game. You get full source code. If your game has less than 10K CCU peak, you can integrate the SDK and even run a source available backend yourself
Mhm.
for free with full source code. And only when your game goes above 10K peak CCU is there a license fee. That's a 25K license fee per year per game. And on top of all of this, we have a managed service where we'll run it for you if you want. Full white glove service where we'll help you with integration, spin up the network, spin up the relays, run the back end. I'll get paged at 2 a.m. and wake up and tell you that something's going wrong and fix it.
Yep.
But I mean, I just want to speak directly to any game developers working on netcode watching this. It's like I've seen things that
Yeah.
are wild.
Yeah.
If you are launching a multiplayer game for the first time, if you haven't launched a multiplayer game and seen this frustration of some players, you just can't fix them. They're just going to complain. They're just going to churn out of your game. Players in particular regions, or even players in the US that just the roll of the dice for their connection right now to the server is not so good. They get a bad experience when they try your game out after launch and they never come back. So this is a huge thing, and it's extremely hard to launch and have a successful multiplayer game in 2026. It's been absolutely brutal out there for 2 or 3 years now. You need every chance you can get. Every player, you want them to stick around.
Yeah.
So let us help you. Let us help you.
And I think this is especially important at this time now, where you have the AI coding agents. You're going to have a lot more games being developed, right? So every way you can optimize your player experience, right, is incredibly important. And I just love that this is available to every single developer, through an open source SDK that can go implement it right now. And then I know you're there to help out as well. What's the next step for developers in order to kind of jump into this right now? Should they reach out to you directly? Obviously, going on the Network Next website and checking it out. What's the call to action here?
Just email me, Glenn, 2 N's, at networknext.com, or find me on LinkedIn. And when we're recording this, it's near the end of February. Hopefully you're seeing this before GDC 2026. If you are, email me, message me. I'm happy to spend some time at GDC with you, show you some of the stuff, share with you some of the things that I've seen, and see if I can help out.
That's awesome. Well, Glenn, we'll see you at GDC.
All right. Thank you.
All right. Thank you.
Cheers.
Bye.